Good morning to everyone and Dr. Sumiyamas. The topic of my today's presentation is Microchip Design Process from Unit 5 ASIC Design and Testing. On completion, the students will be able to understand the overview of several stages in microchip design procedure and also identify the issues in test and verification of complex chips. Microchip design process. A microchip is a unit of integrated circuitry that is manufactured at a microscopic scale using a semiconductor material such as silicon or germanium. The microchip design process involves several stages from conceptualization to production. And the chip design is defined as the process of designing a chip. The process of chip design involves the knowledge of circuit design as well as logic formation. All chips are made using basic element transistors. The MOSFET is the basic building block of digital chips which is used to make complex circuits. The overview of the design process is as follows. Specification. In this stage, the requirements and the functionality of the microchip are defined, and the designers work closely with the stakeholders to understand the application and performance targets. Architecture design. The chip's high-level architecture is developed including selection of components, interconnections as well as overall system design. This stage focuses on defining the chip's functionality and how different components will be interacting. RTL design. The register transfer level design is created describing the chip's behavior using hardware description languages like Verilog or VHDL. The register transfer level design forms the basis for the later stages in the design. This implies that the Verilog code describes how data is transformed as it is being passed from one register to another. The transforming of the data is performed by the combinational logic that exists between the registers. Functional verification. The register transfer level design is extensively tested to ensure it behaves as it is being intended. Various verification techniques such as simulation, formal verification as well as hardware emulation are being employed to identify the design bugs, issues and solve it. Synthesis and physical design. The register transfer level code is synthesized into a gate level netlist which represents the chip's physical implementation. The physical design phase involves floor planning, placement, routing and optimization to meet the timing as well as area constraints. Design for testability. Techniques like scan chains, built-in self-test structures, boundary scan are being added to make the chip more testable at the time of manufacturing. Manufacturing. The final design is then sent to the semiconductor foundry where it is going to be fabricated. This process involves photolithography and other further steps to create the actual silicon chip. Testing and quality assurance. After the silicon chip is being manufactured, the chips undergo various testing methodologies to ensure that they meet the desired specifications and are also free from bugs and defects. Issues in test and verification of complex chips. Complexity. As the chips and system on chip becomes more complex, the verification effort is also increased exponentially, ensuring all possible scenarios and corner cases are covered in the testing, and this becomes a little bit challenging effort. Verification time and cost. With the growing complexity, the time and cost required for the functional verification is also getting increased. Integration testing. Integrating various IP cores and subsystems on a single chip or system on a chip, it introduces new challenges in testing the interactions between such components. Power and clock domains. Handling multiple power domains as well as clock domains in a chip require careful verification to ensure proper functionality and also reduced power consumption. Performance verification. Ensuring that the chip operates at the desired performance level under all conditions and workloads. and this is very important especially for high performance chips. Test generation. Generating effective and efficient test patterns to cover various fault models is a non-trivial task, especially for complex designs. Debugging. Identifying and debugging issues in large and complex designs can be time consuming, and it requires advanced debugging techniques to be followed. Quiz questions on microchip design process. Write down the several stages in microchip design procedure. List down the issues in testing and verifying complex chips. Thank you.